Grandpa, every day I see the sun rise in the east and set in the west. Does that mean the sun will be circling the earth?
For thousands of years, people lived on what appeared to be a stationary earth. Each morning when they arose, they saw in the east the sun beginning to rise. The sun would appear to move across the sky slowly. At noon, it was overhead. Then it continued to make its way west until finally, perhaps at 5, 6, 7 o'clock, it appeared to set in the west. The next morning, about 12 hours later, again in the east, there was the sun moving across the sky. What would you think? Exactly what they thought. Of course, the sun was orbiting, circling the earth. People believed that for thousands of years, and who could blame them? One day, a very intelligent man invented a telescope. Up to this time, all they could see in the sky was what they could see with their eyes. And they had counted approximately 1,033 stars. With the telescope, they could see that there were thousands of stars up there, and it brought things that were far off close at hand. With the invention of this telescope, a scientist by the name of Kepler, and then Copernicus, and then Galileo realized that the earth was not being circled by the sun, but rather the earth was orbiting on its axis. Now that got Galileo in a lot of trouble with some people in the church. The reason for that was that Psalm 19 tells us that the sun travels at a very fast rate of speed through the skies. Now people assumed that that meant, because what did they see? They saw the sun rise in the east, move across the sky, and set in the west. So they assumed that it meant that the sun was traveling around the earth. But that wasn't true. The Bible does not say, Psalm 19 does not say that the sun is traveling around the earth. It simply says that the sun is traveling at a very fast rate of speed. As a result of this, and as a result of the fact that Galileo perhaps was a little bit too forceful, Galileo got into trouble, and he was almost excommunicated from the church. Now, today we do know that the sun does move, but it doesn't move around the earth. The sun, with the planets revolving around the sun, the asteroids moving around the sun, is moving through space at an incredible speed, 500,000 miles an hour. Now that's fast. So the Bible is still accurate. Psalm 19 is accurate. The sun does move at a fast rate of speed, except that it doesn't move around the sun. It is traveling through space.
Grandpa, what do you mean when you say the earth turns on its axis?
Let's just suppose that there were a gigantic ball in the sky that was slowly rotating, okay? And let's suppose there was also a giant light in the sky that was shining down on the ball. Let's suppose that you were attached right here to that ball. As it was slowly turning, the light was stationary. It was not moving. But you would see the light moving. It would appear as if the light was moving, when in reality, you were rotating. The earth was orbiting on its axis. So in reality, when we really look at it, in spite of the fact that it appears as if the sun is turning around the earth, in reality, we are rotating on our axis. So the Bible is still true. The earth rotates on its axis at 1,040 miles an hour. The earth rotates in an orbit around the sun at 67,000 miles an hour. And the sun, with all the planets, with all the asteroids orbiting around it, is traveling through space at 500,000 miles an hour. So the Bible wasn't wrong. It was just that we read into the Bible something that the Bible didn't say. We've already learned that the earth is round. Well, it's not exactly round. It's more like a grapefruit. Flat at the North Pole, flat at the South Pole, and it bulges somewhat around the equator. It measures 8,000 miles across, and the circumference of the earth, that means if we walked from one spot, walked completely around on the equator, it would be about 25,000 miles. The equator is equal distances from the North and South Pole. So if it's 25,000 miles around, half of 25,000 miles around from here to here would be 12,500, and half of that distance would be 6,250 miles. So if we make a mark here, 6,250 miles on the circumference, and we do that all the way around. We do that all the way around, then we have a line completely around, which we call the equator. Now the earth bulges a little bit at the equator. The reason why it's flat here and bulges here is our friend centrifugal force, which we will learn a little bit more about later. Now let's take a rod, an axis. An axis is a point on which something rotates. An axis can be real, as in the case of a chicken on a rotisserie, or it can be imaginary, as an ice skater spinning around and round on an axis. The Earth's axis is imaginary. Let's take an axis and put it from the North Pole to the South Pole. There it is, okay? And as we rotate this grapefruit around, the sun is shining mostly on the equator, the hottest on the equator, and of course the heat is greatest on the equator. Have you ever seen a chicken on a rotisserie? The chicken is on an axis. As it rotates, the heat from the rotisserie is heating up the chicken and broiling it. Now, we want to broil the chicken and get it real hot, but we don't want to get that hot. The Earth is very much like that. It receives its heat and light from the sun, which is 93 million miles away. And the distance is critical. The orbit of the Earth around the sun must be exact. And the Earth has an orbit of almost perfect 93 million miles at all time around the sun. If there is a differential of 1 or 2%, we will either broil like the chicken or we will freeze like an ice cream pop. Isn't it fortunate that the Earth is just the right distance away from the sun? Not too far, not too near, or else we would be broiled alive. Isn't it fortunate that the Earth rotates at just the right speed, or else we would get too hot during the day and too cold at night? Do you think that this is all an accident? Or do you see a plan and a planner? In the beginning, God created the earth, the sun, all living things. One other thing, to a large degree, it is the turning of the earth that causes the waves in the ocean. Without the waves in the ocean, there would be no fish. Fish need air to breathe. Now, no, fish don't have lungs, but fish do have gills, and the gills remove the air from the water. Well, how does the air get in the water? Well, I know how it gets in the water in a fish tank. If I have a fish tank and I have a bubbler in there, you see the bubbles come from the bottom all the way to the top. Now, the bubbles that come out the bottom don't all reach the top. Many of them melt in the water. Yes, gas can melt in water, just like CO2 melts in water and we add flavoring and it becomes soda. So air can melt in water in order for the fish to get the air to breathe. Now, without the winds, with the help of the moon and with the help of the gravitational force of the sun, the waves cause the air to be melted in the water for the fish to be able to breathe. Without them, there would be no fish in the sea. One more thing. It is the rotation of the earth that causes the Gulf Stream. The Gulf Stream carries heat from the equator up to the northern regions and warms up the coast of Britain, France, and Italy. The Gulf Stream has many, many other reasons for being. If it weren't for the Gulf Stream, the fish would not get the nutrition to live. The plankton would die because it is the Gulf Stream that moves the nourishment that comes in from the rivers from the land and moves it up to a place where the plankton can get that food, eat it. The plankton are the bottom of the food chain. And without the bottom of the food chain in the sea, there is no food chain. Why does the earth orbit on its axis? It's because God loves you. And he made it that way so that you could live on this wonderful planet we call Earth.
Grandpa, what would happen if the Earth didn't turn on its axis?
You asked the question, what would happen if the Earth didn't rotate on its axis? Well, think for a moment. Half of the Earth would get sun day and night, and half of the Earth would never get any sun. This area would be cold. This area would be very hot. Now, think for a moment. What is the hottest part of the day? About 3 to 4 o'clock. When is the Earth receiving the most heat in the form of rays, which is actually translated into heat? What time of the day does the Earth receive the most of those rays? 12 o'clock noon. Well, why then isn't it the hottest part of the day? Because the heat is building up during the day. And it continues to build up at 1 o'clock when the heat is reduced, at 2 o'clock when the heat is reduced. The heat on the Earth continues to build up. 3 o'clock, 4 o'clock. Just visualize if there were never a night for the Earth to cool off. This area of the Earth would be incredibly hot. It would be totally impossible to survive. On the other hand, this area of the world would receive no heat, and it would be incredibly cold. This area would, in a short period of time, freeze solid. The oceans would be a solid block of ice, never to defrost.
Grandpa, if the Earth turns at 1,000 miles an hour, why aren't we thrown off into space?
Wow, Christy, that's really a great question. In order to understand that, we're going to need to understand a little bit more about centrifugal force and gravity. Centrifugal force. There's a basic law of nature which says that an object moving tends to move in a straight line unless restrained by an outside force. For instance, you've all seen a softball pitcher pitch, or at least I think you have. Now, let's assume that I'm the softball pitcher. I whirl my arm around in a circle. What keeps the ball from flying out according to that law? Well, it's my hand. It's the strength of my hand. You'll see centrifugal force, and then we will see the force of gravity pulling it to Earth. Here's another way that we can illustrate centrifugal force. This is a rubber ball which is attached to a rubber string which was attached to a paddle. You know, the ones where you go ba-bang, ba-bang, ba-bang. We took the paddle off, and here it is. Supposing we begin to whirl this around slowly in a circle. If it's slow, it's okay. But as I increase the speed, notice the ball flies out further and further and further. Eventually, if I increase the speed, the ball will break the rubber band and fly out in a straight line. What caused the difference? Centrifugal force.
Grandpa, the Earth travels at 67,000 miles an hour in orbit around the sun. I see no rubber band or steel cable holding it in orbit.
We know there is no rubber band holding the Earth in place. There is no steel cable holding it in place. What holds it in place is a mysterious force we call gravity. The sun is 1.5 million times the size of the Earth. The sun has a gravitational pull toward the Earth. And the Earth has a gravitational pull toward the sun. These need to be exactly right. The speed has to be exactly right. The proportion has to be exactly right, or else they will either be pulled in toward each other or away from each other. A 1% difference would mean that we would be frozen like a solid block of ice or fried like a chicken.
Grandpa, why does an apple fall down from a tree and not up?
One day, a devout Christian by the name of Isaac Newton was at home on his mother's farm. The reason he was there was that the bubonic plague had devastated Europe. 1/3 of the population was wiped out. He had been attending Cambridge University, and the colleges shut down in order to prevent the spread of disease. And so Isaac went home. He was sitting on the farm under a tree, probably meditating, because he spent a great deal of time studying God's Word. And as he was sitting there under the tree, an apple fell from the tree and hit the table in front of it. He began to think, why did the apple fall down and not up? He thought more and more, and he looked at the solar system. He asked the question, what holds the Earth in orbit around the sun? What holds the planets in orbit around the sun? And he realized that there was a mysterious force called gravity. He learned many things about gravity. Now, we still don't understand what gravity is. He learned that the gravitational force depends upon the size of the object. In other words, the sun has a much greater gravitational pull than does the Earth, which is, the sun is 1.5 million times as large as the Earth. The fact of the matter is, I have a gravitational force. Because I'm not that big, you can't feel it. All things in this room have a gravitational force. And they depend upon several things. The density of the object, the weight of the object, and the distance that each object is from each other. The closer the distance, the greater the gravitational force. The further away, the weaker the gravitational force. Without the force of gravity, there would be no life on the Earth. For we would be thrown, the air would be thrown, the oceans, and everything on the surface of the Earth would be thrown off into space by what we have learned about already, centrifugal force. No one understands gravity, and yet it is there. That does not affect the fact that it still overpowers centrifugal force and keeps us here on Earth. In many ways, that's a lot like God. There are many people who say, I don't understand God. I don't see him. I don't touch him. I don't feel him. I don't smell him. Therefore, he doesn't exist. Well, we don't use that logic with gravity. We don't understand all of that, and for thousands of years, no one knew it existed. And yet, we continue to live. I am not required to understand God. My only requirement is that I love Him, I serve Him faithfully.
Grandpa, is gravity something like a magnet?
The fact is, no one really understands what magnetism is. We know what it does, but we don't know what it is. The life that which we now live, we couldn't possibly live without magnetism. Magnetism is, in a sense, a black box. A black box is something which we know it works, but we don't know why it works. I taught electricity in school for 25 years, and yet I don't know what electricity is. I know what it can do, but I don't know what it is. You go into a kitchen in your home, and you open a refrigerator door. It's a black box. You don't know what makes that black box work. You go to the stove. You don't know what makes that work either. In actuality, most of the appliances in our home operate on magnets, magnetism, and electricity, and yet we don't know what they are. Your father, or your mother for that matter, may be very, very experienced and knowledgeable in the field of electronics and may know how to use a computer. Yet no one really understands how a computer works. There are many, many parts of a computer which are completely unknown to us. There's no one in the world who fully understands the operation of a computer. Does that prevent them from using the computer? The fact is that you and I are black boxes. Take a deep breath. How many of you understand what you just did? Oh, you know that you took in air, which is composed of about 21% oxygen, 0.4% of CO2, and nitrogen, and some trace gases. You know that. But did you also know that we, every one of us, are composed of trillions of individual living cells? Now, that's a lot easier to understand today than it was years ago when we take one person's heart out and put it in someone else. We understand that the heart is alive apart from the person. But our cells have an individual life, and every one of those cells requires oxygen, requires a method of disposal of the CO2, which is generated by the combination of the oxygen combining with the food that goes into the individual cells. How is that accomplished? First of all, how do you get the oxygen to every cell in the body? Oxygen in the bloodstream will kill you. How do you get it from the lungs to the individual cells? Did you know that in your bloodstream there's just a few molecules of iron? That iron is essential for life. Oxygen is a very aggressive gas. It attempts to combine with everything. The oxygen combines with the iron and instantly becomes rust. Passes into the bloodstream. As it passes through the bloodstream, each individual cell plucks out the oxygen, leaves the iron behind, uses the oxygen to combine it with the food, the nourishment that it took in, and the waste product is CO2. What do we do with the CO2? CO2 in the bloodstream is equally as deadly. What happens is that the CO2 instantly combines with potassium and becomes baking soda, harmless baking soda, which is deposited into the bloodstream. The bloodstream carries the baking soda back to the heart and out through the lungs, where the CO2 is plucked out, the potassium goes back into the bloodstream, out comes the CO2. Fortunately, CO2 is heavier than air, and it sinks to the lower part of the earth, where it is needed for the vegetation to live. You think that's all a series of accidents? Nah. There's design involved. There has to be. A brilliant physicist, Nobel Prize winner, said, where there is a plan, there must of necessity be a planner. Can you see the hand of the planner? Do I fully understand how the oxygen gets to every one of the cells and how it disposes of the CO2? Of course not. But I keep breathing just the same. Do I understand how when I go to sleep, I keep breathing? No, I don't really. But I keep breathing just the same. I don't have to necessarily understand something to enjoy its benefit, just like the refrigerator, the stove, the air conditioner. You may not understand these things, or the computer, but we use them. I don't have to understand God to know He is there. I just have to trust Him, believe Him, and obey Him. To make an electromagnet, we take copper wire, or aluminum wire for that matter, and we wrap it around a piece of iron. The more turns we make, the stronger the magnet will become. If it's soft iron, and that doesn't mean you can take the iron and bang it over somebody's head and it won't hurt him. It means it's softer than steel. Steel is very hard. To make a temporary magnet, we put electricity through both ends of it, and this will become a magnet, as long as the electricity is flowing through it. If I wish to make a permanent magnet, I can use steel, hard steel, and I can wrap the wires around the same way and put electricity through it. It will not be as strong a magnet as the iron magnet, but it will be permanent. So even after I take the electricity away, it will remain a magnet for a period of time. Some people say, how can you understand or believe in God when you don't understand Him, or see Him, or touch Him, or feel Him? That's not logical, is it? After all, if I use a refrigerator, I don't understand it. If I use an automobile, I don't understand it, or a computer, I don't understand it. I really don't have to understand something to use it. In like manner, I don't have to understand God as long as He understands me. That's the problem. I don't have to understand God to believe Him. I can see His hand all around me. I see the design in the stars, in the sky, on the land, in the trees, in the air. I see His hand all around me, and I see that He is there and recognize His presence. Where there is a design, there must, of necessity, be a designer. Isaac Newton said, when asked, aren't you proud of the fact of all of your accomplishments? He said, me? I feel like a little boy standing on the seashore. If you take all of the sand in all of the seas in all the world, that is as the knowledge of God. Me? I've picked up a few grains of sand. That's all. Even the atheist Einstein said, the heavens reveal an intellect of such overwhelming magnitude that were the intellects of every individual who had ever lived been combined, they would in their totality be insignificant in comparison. My little 6-month-old child or grandchild is not as intelligent or as learned as I am. How can I expect to be as wise as God? God said to Job, when Job asked him a question, God responded, Job, did I ask your advice when I measured out the span of the ocean? Job couldn't have known that. And for thousands of years, we didn't know why he made the oceans in the way that he did. Today we know much more. We still don't know all of it. I am but a child in the eyes of God. How can I expect to understand him? My obligation to God is not to understand him, but to love him, to serve him, to obey him.
Grandpa, will two magnets attract each other?
That was a great question. Magnets have two poles, a north and a south pole. Remember this, like poles repel, unlike poles attract. Let me show you what I mean. If I put these two together, watch what happens. Now I am exerting force here to keep this one in place. I'm going to force it to go there. Watch what happens when I release my hand. We had two like poles. Okay? Now, supposing I reverse that, well, you saw what happened all by itself. Okay? Two unlike poles. From this distance even, they attract, they come together. The North Pole, at the North Pole, is a strong magnetic force. One of the most useful purposes of a magnet is on a compass. What is a compass? A compass is a magnet that is free to turn. And if we place a compass on something, or rather if we place a magnet, a permanent magnet incidentally, on something where it is free to turn, the north will always face, or rather the south pole will always face the north pole. We can use that in a number of ways. One way we can use it is we can tell where we're going. Hundreds, if not thousands, of people's lives have been saved because of a simple device called a compass. For many years, there was only small amounts of electricity that was available. I would say even today, 95% of all electricity is generated as a result of magnets. How did this all come about? One day, a scientist by the name of Hans Oersted, I believe his name is pronounced, was sitting at a table. And on the table, he had a battery. Now, first of all, what is a battery? A battery is two dissimilar metals, two different metals in a container, immersed in an acid, some kind of an acid. It can be a strong acid or a mild acid. When you have two dissimilar metals, there is an electrical flow from one of the metals to the other metals. And if you put a meter between them, you will see an electrical flow across the two wires. That's a battery. The battery in your car is two dissimilar metals in sulfuric acid. Well, in any event, he had a battery on his table. As a result, very few things could be done with electricity because the supply was small. Okay, in any event, they didn't know a great deal, so they couldn't do anything anyway in those days. Now, he happened to have a compass on his desk, and the compass was facing north. He took a wire that he had, and he put it on the battery, okay, and he attached the battery, both ends of the wire, to the battery, and lo and behold, he was astounded. The compass swung around. What's going on here, he said. He took it off, and he tried it again. Sure enough, the compass again faced north, and when he attached it again, the needles swung around. Now, he made a very, very important discovery, a discovery which has a tremendous impact on the world. He discovered that when electricity passes through a wire, a magnetic force is formed around that wire. That was a wonderful, wonderful discovery. Another man by the name of Michael Faraday, a few years later, was in England, brilliant Englishman. And he had a thought. He said to himself, I wonder If I take a magnet and pass it by a coil, where the electricity will flow through that coil. And he tried it. He took the coil, he attached it to a meter. And then he took the magnet and he passed by, and sure enough, the meter moved. That simple discovery has changed every one of our lives. There would be no refrigerator in your kitchen. There would be no automobile. There would be no airplanes. There would be no locomotives operating the way they do. There would be no computers. Virtually everything in our life here on Earth is affected by the two discoveries that these two gentlemen made. One of the first uses of a magnet was to separate metals. In other words, if we took a magnet, an electromagnet, and attached it to an arm, and we placed it down, or to a crane, let's say, and put it down, it would pick it up. Okay. Well, it picked it up. Okay, now, if we disconnected it, it would drop. Now, you've all seen that. I guess if you've been to a junkyard, you've seen that. One of the next places where it was used was in the telegraph. Now, this is a very, very simple telegraph. Okay? First, we want to bang this in. Okay? Visualize an operator standing here with wires in between. Perhaps the wires may have even gone across the English Channel. Okay? This was on the other side, and here we are, and we make and break it, dot, 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 SOS, save our souls. A telegraph. Very, very simple device, but that too has saved many, many lives. Isn't it interesting? We take electricity, which we don't understand, we put it into a coil, and we find that magnetism is created, which we don't understand. We take that electricity, and we put it into a magnet, and we move that magnet, and we create a gigantic generator which produces electricity, which we don't understand. We use all of these things. We use the automobile, we use the refrigerator, we use the computer, we use all of these black boxes that we don't understand, and we have no problem with that. Why then should I have a problem when I can't understand God, as long as he can understand me, and he understands me very well, sometimes better than I want him to. He understands me very well. I am but a child in his eyes. It is not up to me to understand him. It is up to me to love him, to serve him, and to obey him.
Grandpa, how does a light bulb give off light?
Well, my love, it worked this way. One day, somebody took a wire and put it between two terminals of a cell. The wire got red hot, then white hot, and then in a flash of light, it burnt out. Thomas Edison one day thought about it, and he thought, what if I could make some kind of a device that would provide light in a home? Up to that time, they used oil. Now, the oil may have come from whales, or the oils may have come from petroleum, or it might have been some kind of fat, or they used gas, or they used a candle. But all of these things had open flames, and that could cause a lot of fires, and many people died because of the fires. Thomas Edison thought about it, and he looked for a long time for a material that would not burn out. He finally came to the conclusion that a metal called tungsten would be the best metal to use. And it lasted for a little while, but it too burned out. And then he had a sudden thought. What is a fire? A fire is oxygen combining with a material. There are many different kinds of fires. Combustion occurs when iron and oxygen gets together and it rusts. That's a form of combustion. But a fire is a piece of wood, the materials in a piece of wood turning to gas and combining with oxygen and making a fire. He thought, what if I could somehow or other put the tungsten inside a globe and remove the air, make a vacuum? He did it, and it worked wonderfully. Worked a long time, but there are several problems involved in this. One is that the globe was very fragile. Why? Because there was nothing on the inside, and there was pressure on the outside, and any little tap on the glass, bam, it splintered. Okay? There was another problem. It costs a lot of money to make a vacuum in a globe. So that's a second problem. And the third problem is that no matter how hard he tried, it was extremely difficult to make a perfect vacuum. Then suddenly, he got a brilliant idea. What if I replace the air with a gas that doesn't burn? So he filled the globe with argon, which is a very rare gas which doesn't burn. I think 1% of air is argon, if I'm not mistaken. He put the tungsten inside, filled it with argon, rather, and sure enough, the life expectancy of the bulb increased tremendously. What a brilliant series of ideas. If a light bulb can think, if tungsten, a globe, and argon gas can't think to come together to form a bulb, what of this marvelous home that we live in, Earth? It is incredibly complex, beyond our wildest imagination. It is incredibly complex. Looking at it, you have to see the hand of a designer. And what of the human body, which you and I are? God's masterpiece. We are an incredibly complicated design. Could all of this have happened as a series of accidents? Or do we, when we look at these things, see a design and the hand of the designer who created it all? In the beginning, God created.
Grandpa, why is Snow White?
Making Snow White was one of the most important decisions that God could have made. It affects life on Earth in a way that you can't possibly imagine unless you think about it. As an example, let's supposing there were a gigantic snowfall like they just had in Buffalo, 7 feet of snow. Supposing we took 2 foot-square pieces of metal. One of them was white, and one of them was black. And we took the 2 pieces of metal and we laid it into the snow and walked away and came back a week later. The sun shone during the 2 weeks, or the week later. We wouldn't hardly find the black piece of metal because it had absorbed the heat from the sun and had sunk down into the snow. The white piece of metal, on the other hand, had reflected 90 to 95% of the rays that shone upon it and didn't sink into the snow at all. All of that is an integral part of the design of planning the Earth. Let me explain why. Have you ever wondered why in cold climates the roofs of houses are black? That's to absorb the heat from the sun. Have you ever wondered why in the tropics the roofs of houses are white? That's to reflect away the heat of the sun. Have you ever wondered why in cold climates people tend to wear dark clothing? That's to absorb the heat of the sun. And have you ever wondered why in hot climates people wear white clothing. That's to reflect away the heat of the sun and keep them from overheating. The colors of snow is extremely important for many reasons. Number one, visualize a gigantic snowfall. It's cold. The snow remains in the form of snow. Now comes spring. The sun begins to shine on the white snow. If it were black, what would happen? The snow would all immediately melt, and we would have a gigantic flood. We have floods as it is. But if snow were black instead of white, we would have a gigantic flood, and life would be very, very different than it is today. There are other reasons as well. There are many areas of the world where there are no lakes and there are no rivers to get fresh water from. They get their water as a result of snow being white, believe it or not. At the North and South Pole, there are huge areas of snow and ice, white. The heat is reflected from that snow and ice back into space. Try to visualize what would happen if snow were black. The snow would melt, the levels of the ocean would rise, countries like Bangladesh would be completely underwater. Most of the islands of the sea would be completely under the water. The fact is that the probability is right where we're sitting right now would be underwater. The levels of the ocean would rise that high if snow was black. We might also say that God could have said to Job, "Did I ask your advice when I made the color of snow?" There are many other reasons as well. Life in the ocean depends upon the snow being white. How can that be? Well, the snow builds up at the North Pole. The snow buildup slides down toward the ocean, pulled by our old friend gravity. After a period of time, a large block of ice breaks off and floats into the sea, and we have an iceberg. There have been icebergs. As a matter of fact, last winter we had an iceberg that was 120 miles long, I believe, and 22 miles wide. That's a big iceberg. Well, what does the iceberg do? Without the snow being white, there would be no icebergs. There would be very little snow in the North and South Pole. Well, how does that affect the fish? Very simply. The ice floating in the water makes the water around it extremely cold. That water becomes heavier than the other water around it and sinks to the bottom of the ocean. There is a river in the ocean called the Gulf Stream. It flows at several miles an hour at the bottom of the ocean. The volume of the water is, if I remember right, 100 times the volume of the Amazon River. It is a tremendous body of water that slowly moves toward the south. Okay, as it moves toward the south, it stirs up the chemicals which were brought into the ocean by the rivers flowing into the ocean. Those chemicals are stirred up and come into a position where the plankton can reach it. The plankton eat the nourishment, and in turn are eaten by baleen whales and all of the small fish, and they in turn are eaten by bigger fish. There would be no plankton without the icebergs. There would be no icebergs without the snow being white. That river continues to flow south, picking up heat, tremendous volumes of heat in the tropics. Then as it moves its way north again, right around Italy, and begins along the coast of Europe, it begins to release its heat and warms the areas around it, warming France, Sweden, Ireland and England. The temperatures of those countries would be much, much colder were it not for the Gulf Stream. There are other things that the Gulf Stream does as well. Have you ever wondered how the fish at the bottom of the sea get oxygen to breathe? That's a tough question. How come one of you didn't ask me that question? That's a tough question. Let me tell you how it happens. The water at the surface of the ocean in the tropics is being stirred up by the winds and the waves and the tides. It absorbs oxygen. As that oxygen moves its way north to the iceberg, that oxygenated water now becomes colder than the water around it and sinks to the bottom of the ocean, providing the oxygen for the fish down at the bottom of the ocean. Why did God make Snow White? He made Snow White because he loves you. He knew that in order for there to be life on the earth, snow had to be white.
Grandpa, how do people get a drink of water if they don't live near a river or a lake?
That was an excellent question. What's the most important thing that a group of people needs when they settle an area? Food? No. Many people can live as much as a month, sometimes even 2 months without food. Water. Once you go beyond 7 days or thereabouts, you cannot survive. So the first thing that anybody looks at when they intend to settle an area is there water? Well, what do people do when there is no water around? Most people live near the coasts, near the rivers, near lakes. But how do the people who live in the interior parts of the country, and that's another interesting question that we'll have to deal with a little later on, why God designed the earth the way he did, how do they get their water? Did you know that there are underground rivers which are greater in volume than the Amazon River? You remember Jacob coming to a well, and there he found his wife at the well, the woman that's going to be his wife. Where was that water coming from? Apparently, that well was tapping into an underground stream or an underground body of water. We read about many wells in the New Testament. When we read about Abraham and Jacob and Joseph, we read a great deal about wells and the water coming from the wells. How does the water get there? Why did God make Snow White? Because he knew that people who didn't live near a river needed water. Here's what happens. As the snow slowly melts, it sinks into the ground. What pulls it down to the center of the earth? Our old friend, gravity. Water is heavy. And if there is not solid bedrock underneath, the water will continue to go down into the earth. Now, if snow were black, the water would have melted in one shot, gone. No water to slowly sink down into the earth. Since water is white, or rather snow is white, and since it melts slowly, the water is pulled slowly down into the earth to form the underground rivers and streams so that people who do not live near the coasts or near rivers or lakes can have the water to drink. You know, God thinks of everything, doesn't he? Well, that's why he's God, and we're only man. Is it just a fortunate accident, a stroke of luck, that snow is white? Or is it more logical to assume that it's part of a great plan by a great planner who loved us and loves us and provided this wonderful, wonderful planet Earth, so very different from every other body in the solar system. The heavens, the earth, declare, shout out the glory of God, its designer.
Grandpa, if snow is white, why is soil black?
That's a great question. We know why snow is white, or at least we know a lot of the reasons why. But why is Earth black? We've learned that white reflects the light. Snow, or rather black, absorbs the light. The Earth is black. The sun shines directly on the equator, where it is extremely hot. But as you move away from the equator, the sunlight is indirect to a large degree. And some of it would be reflected away, and some is reflected away. The fact that the Earth is black and heats up quickly, Earth heats up quickly, is the reason why we have food to eat. If the Earth did not absorb heat quickly and heat up quickly, there would be no seeds sprouting. There would be no peach trees, no plum trees, no mangoes, no fruit to eat. There would be no vegetation, and there would be no cattle to eat the vegetation. Why is the earth black? Why is soil black? Soil is black because it is a part of an apparently great plan to make possible here life on the earth. Why is earth black? Because God loves us and provides for us in many, many different ways. In the beginning, God created the heavens and the earth.